Hey guys, welcome back. I'm gonna do this video inside. It is, if you can see that, 111 degrees. That's right, outside. So this car being black, you know, it's just one of those things where I don't want to burn up in this car. This car does attract a lot of heat. So what I'm going to do, I'm going to discuss on this tutorial the Xdrive, what it is, how it works, and how you can benefit from it. So keep watching. All right, so what is Xdrive? If you have any all-wheel drive BMW, most likely it is an Xdrive. I'm speaking more specifically on the the X5s in general, but this could apply for X3, X1s. You know, we can go. Yeah, most of the all-wheel drive ones are like this. So Xdrive is basically BMW's all-wheel drive system. All right, so what it can do, it can transfer power from the front to the rear and adjust it accordingly based on the demand for traction. Okay, so by this being BMW, obviously they want to make sure everyone can enjoy the benefits of having rear-wheel drive. You know, that is where the real feel of having, the driving is rear-wheel drive. Primarily the car is going to be shifted most of the power to the rear wheels, so you get the best driving dynamics. However, if the rear wheels slip, the computers can send power back to the front basically quickly than what you can even realize. By the time you, the driver, realize there's tire slippage, the computers already have beat you to it and move more power to the front axle. Okay. Now, this works majority of how most smart all-wheel drive systems work. I mean, you have, 4MATIC and Mercedes, you have Quattro and Audi, you have, Chevrolet's version, Ford's version. But what really makes these cars, so when you get to some of the other more advanced all-wheel drive systems, you hear about Subaru having an advanced all-wheel drive, you hear about Audi having one of the best. What makes them good is that not only can they shift power front to rear, because that's a good smart system, right? It can shift power front to rear and adjust it accordingly, but can they shift power side to side, right? So if we're behind the car and we'll say we want to shift power from the right side to the left side and vice versa, can the car do that? Yes, it can. So you're thinking, well, Eddie, what situation where I feel like I'm gonna have one side of the car on traction? Well, it depends. What if you're stuck? If you're stuck in a situation where you might have one tire on pavement, other tires on, just being an exaggeration, other tires are on ice, that one tire could be your lifeline to getting you out of that situation. All right, now if you're driving something slippery, if you got four wheels on the ground, a two-wheel drive car could easily lose traction and have two wheels slipping. But you have four wheels, so you may have one or two wheels that could be benefiting you and giving you some traction. All right. If you go to the M models, they can actually use Xdrive to help the car turn better. That's right. Which is called a torque vectoring. All right, now that's mainly on the X5 M's, X6 M's, and some of the other M, like the M5 and stuff like that, where they all-wheel drive. Now, torque vectoring is slightly different than, it's more advanced. Basically, it's Xdrive, but it's slightly more advanced. It can actually take power and overdrive the outside wheels to help the car turn faster around the curves, right? And you're thinking, well, how can one wheel turning faster make a car corner better? well, something like this. Let's take a lawnmower. Let's take a zero turn lawnmower. All right, these zero turn lawnmowers have no steering wheel. There is no steering on these. The way that these small lawnmowers steer is by using levers. Okay, you push one lever forward and it overdrives that wheel, that particular wheel, and then you could pull one back and it actually could slow that wheel down and or reverse that wheel. Doing both at the opposite direction could cause you to make you do a 360, but making small corrections, small turns by using the levers can actually turn this mower, and this is how that mower makes turns. So using that same technology, using the computers on these cars, they can actually make these cars corner better, on handling. All right. Like I said, this is more on the M models. I said on the regular X5s or X6 or X3s like that, you're not gonna see that, but I just want to touch on that. So now, how can this? Let's talk about how the benefits and how to use it. It's really easy. You shouldn't have to do anything as a driver. There's no all-wheel drive button to engage. There's no lower range. The car does everything for you. All right. But there are a couple of things you should do as the driver, and a couple of things I'm gonna go inside the car and actually kind of give you some tips towards the end. When the car experiences wheel slip, like extreme wheel slip, and say for example you have one wheel, in my example, one wheel simulating on ice, you got the left front, right rear off the ground, or let's say on ice where they're rotating freely. Xdrive is going to apply braking on those wheels to the point where it will stop them from turning altogether if it needs to be, thereby transferring that power to the other wheel on that axle, right? So we'll go to the power will go into the right front, left rear. Now, using that, when you see it on TV, when you see these guys and they're using on these rollers and these roller tests, and they're having these cars doing it, you just think it's a seamless process, and it is. But as the driver, when the car is actually holding the brakes, the computer is actually holding the brakes, all you get inside is the traction control light. So what people tend to do is think, oh, my car is slipping, it's not going anywhere, let me back off the gas and give up. Well, don't do that. The traction control is letting you know that the wheels will slip and the computers are working. But you need to give the computer time. So what you should do in that situation, at least give it a little more throttle, because the computer is not going to just let it over rev and spin. Traction control does the job, which I'm gonna explain that later in what traction control does, because the Xdrive is integrated with that. But give it a little more gas. Press the gas down more, because now since the computer is holding the brakes down, it needs more power to now send to these. It's already said, okay, you're sending power to these wheels which you're not letting them turn. We need a little bit more power. So give it a little more power, and the car can actually utilize Xdrive to its advantage and distribute the excess power to the other wheels. So by doing that, you should be able to get through most situations. Now, if all four wheels are on ice, then you're done. There's nothing else you can do. It doesn't matter Xdrive Quattro, doesn't matter what you have, traction control, four-wheel drive, low range. If all four wheels do not have traction, then you cannot go anywhere. That's just physics, on its own. That there's no technology behind it that can, exactly pick that car up and move it over to a side that's no traction. You're done. So let's go in the car and we'll talk more about the traction control, and also I'm gonna talk more about hill descent control. All right, so now we're inside. Okay, as a driver, like I said, you don't need to do anything, but you should know what these buttons do. So obviously these are your drive modes. The drive modes for driving actually are circulated in the aluminum trim here, but the traction control is important to know. Now, traction control, let me tell you this now, traction control cannot provide more traction. All right. I've had dealers tell me, oh, if you need more traction, hit that button, or traction control does. No, traction control can only control the available amount of traction that you have. It cannot add more traction to the tires. It cannot magically create give you this extra boost. However, what it can do is it can control the wheel spin to a point where it's optimum for moving, because you want the wheels to not spin to where you dig yourself a hole, but you want them to turn a little bit to help you move. And obviously, if there's a certain point where there's wheel slippage to where the computer sense, hey, these wheels are going to spin really fast, look, the computer can cut the power back. Despite you can put your gas pedal to the floor, it will not let you overspin these wheels. All right. So, why would they give you an off button then? You know, why is there a button to turn it off? Well, you have two different modes to turn it off, and I'm gonna tell you why. Remember how I talked about how the computer doesn't let you do any excess wheel spinning, right? But sometimes the computer can get confused. That's right, it can. And that's mainly if, say, for you are on a really slippery surface, trying to climb a steep hill, and the computer, what it can do, it'll pull back some of the throttle, but also to a point where it may kill your momentum moving somewhere. And you're like, what up? I mean, I got my foot to the floor and I can't climb this hill because the computers won't let me go. That's why you have an off button. Okay, you can temporarily turn it off, but then if you do that, it's up to you. But BMW says, you know what? We're gonna give you two different modes. We're gonna give you what they call DTC, or dynamic traction control. All right, and what that does by hitting this button, so we press it here, you'll see the display changes. Dynamic traction control activated, maximum traction with reduced stability. All right, so what that means is the computer's going to say, okay, we're not going to be as restrictive. We're going to allow you to have a little bit more wheel spin to help you get to where you need to be. Some basically, so we're not going to hold you back. However, if things do get out of control, it's going to intervene. They say, for example, the wheels are trying to turn and they're just doing this because traction control is like, won't let them spin. When you have dynamic traction control, it will let them do this, but it won't let it do that, right? It won't let it just run up and just, sling snow and stuff everywhere, or mud wherever you are. But it can, for example, if you're going through somewhere, you're somewhere thick and you say, I really need to keep my momentum up through this area, you want to activate dynamic traction control just as a safe measure, because when the going gets thick and you start to get through that stuff and you try to give it more gas, the computer's going to deny you that. But at least when you have dynamic traction control activated, it will help. All right, so if you want to turn it completely off, and this is only done in situations where you need to rock the car back and forth. What you do is you press and hold it for like 2-3 seconds. Let's see, I'm pressing and holding now. All right, now it's automatically put me into a sport mode, because sometimes people want that sporty setting. But you see here, you have DSC off, you have traction control off. It is completely off. That means it is up to you as the driver to maintain the stability and the traction. All right, you can use that. I mean, if you want to show off with your kids in the parking lot and do a donut in a snow-covered parking lot, you want to turn it completely off. If you are stuck and you need momentum to rock the car, you need to back up a little bit, until you get wheel spin and go forward and rock back and forth, because you're in a stuck situation, you want traction control off. Because with it on, it's not gonna let the car move. Sometimes you'll notice that, because when you first experience it, it's gonna feel like you're gonna be like, am I even drive? Because the car is not even moving. And that's because, and you'll slip down, you'll see just a light blinking telling you that it's not doing anything. So that'd be the only time you'll actually, I say you should turn it off. But as soon as you get free, especially if you're in snow, reactivate that traction control, because it is integrated with stability control. Stability control is probably another conversation. I could probably talk a little bit about it. Stability control keeps you from spinning out. All right. doesn't really care too much about for throttle input, but say for example, there's something in the road and you need to take a really quick evasive action. You swerve and you swerve pretty aggressively and you swerve back. Now, a car without stability control, what will happen is it may fishtail. The back end may step out. You may find yourself fishtailing, and you might, if you're a good driver, you can recover. If you're a novice driver, you may or may not, and you can find yourself making a lot of left and right corrections, and you might take forever. And a lot of times you get to that point where the corrections start to become overpower the car because it starts spinning one way, you might spin the other way, and you can lose control and spin around. So what stability control does, it sees the yaw movement, and what it will do is it will actually apply braking on one of the four wheels to help get the car back under control. So if the car is going this way, say if it's sliding this way, this direction, it will apply the brake under, I would say, the left front wheel as you're turning, and then what will happen is the car will just rotate back. And before it spins back the other direction, it will then apply brake on the right front wheel and vice versa. If you're in a situation where you're trying to turn, right? You're trying to turn, but the car keeps going straight, wants to plow straight, stability control can apply brakes on one of the rear wheels and kind of mitigate that too. So remember I talked about the mower, right? How it can use that to turn. So if you're trying to turn, it can apply the brake to the inside wheel to help use those to turning. And like I said, instead of accelerating the wheels, it can actually use braking to help the car stabilize. It's not as safe. I wouldn't say that it's a substitute for safe driving. Guys, you still gotta drive safe out there. It's not gonna help you make a turn, 90-degree turn at 100 miles an hour. That's not, like I said, physics still apply. You can't do that. But in these situations, it could benefit you. It can help you. And then, like I said, there's a button there. When I'm on M3, I'm at the track, I feel that these systems are a little bit too proactive, because when I'm taking really like high-speed turns, the system is working. It's trying to keep the car stabilized, but I'm not anywhere feel like I'm near losing control. So I turn mine off in the M3 when I'm on a track, because I'm in a controlled area, to say, okay, I'm going to control it. I'm not on the street. So if I were to lose control, at least I'm on a track where I can kind of recover, and it's not as restrictive, because like I said, it is using brakes, right? So like I said, on the track is using brakes, it can actually overheat them because it's working overtime. But that's why they give you a button to turn it off, right? That's one of the reasons. Hill descent control is another one. So by activating hill descent control, think of it like it's not a cruise control, because a cruise control will automatically give you gas and brake. Basically, a cruise control will automatically adjust your speed accordingly up or down a hill to maintain your speed, right? A hill descent control can control your speed going down the hill. So what will happen is, if you're going down a steep hill and gravity takes the car down the hill really fast, you as a driver, you can just hold the brake and hold the brakes down and let the car do its thing. But it's a benefit, especially if you're going off on a slippery surface. You can concentrate on driving. Hill descent control, you can set your speed anywhere from like 3 to like 10 or whatever miles an hour, and it won't intervene unless the car starts to coast down past that speed that you have set for, and then it will automatically apply braking and try to keep the car under that speed, and then release the braking as needed if it needs to be. And also is using ABS, so it's monitoring the wheels, individual wheels. So when it is braking, it is making sure that they're not slipping, right? And if it does take wheel split, it can actually kind of release and pulsate that particular wheel like ABS would do to keep it rolling and maintain that traction. Like I said, it's beneficial on the street. Probably would never use it. But if you're somewhere where you might have to go down a steep gravel driveway and it's raining outside and it's like this, and you're just like, whoa, I got to concentrate on driving, you just use hill descent control. That's what it's there for. And the way you adjust your speed is you use the cruise control speed selector and use the little rocker switch, and you can adjust your speed either up or down. When the light turns, when it's red, it means it is not on. When it is green, that means it's working. It is holding the car back. All right. So just some things to know. So I have a big hill here, and what I'm gonna do is I'm gonna activate it. It's on. Now I can set with the cruise control switch 7, 8, 9. I can set my mile per hour. So let's say 5 miles per hour. Now I can roll down this hill and drive, and we'll see. And the brakes will only be applied if the vehicle exceeds 5 miles an hour down the hill. So I'm going to release the brake pedal. I'm not going to touch it. I'll let the vehicle do its thing. So roll down the hill, turns green, you know it's active. It's holding the car at 5 automatically. I can go to 6, I can go 7, or I can drop it down to 3, and we'll hold it there. And then go to 3. So if that's 3 when I'm actually moving, we see it's active. You see the green lights flashing, and I can take over from here. Now you're probably saying, well, what's the benefit of hill descent control? Couldn't I just hold the brakes? Yeah, you could. But this is a easy, effective way to hold the car. For example, if I'm going down a steep decline, I'm in an off-road situation, you know, where I mean, you can always put a certain amount of brake pressure on a pedal, but can you hold a steady mile per hour? Or, you know, as you run over rough surfaces, you can be like on and off the brakes accordingly. At least you have wheel sensors monitoring each wheel individually. So, you know, it works with conjunction ABS. It can control the wheel lockup while maintaining that mile per hour you have set. So, I think it's an easy way. That way you can focus on your main task of keeping the car going straight. Like example, if you're off-roading. Guys, hope this video was helpful. If you like it, give me a thumbs up and subscribe. Thanks for watching.